Hello students, my name is Sanjay Jain. Now that we have finished number system, let's move to the next chapter, that is polynomials. Polynomials is an interesting chapter because it is just the extension of what you have studied in your previous classes about algebraic expressions, right? Polynomials are a special type of algebraic expressions. Now let us start with the notion of algebraic expression. We know that if we write something like x plus 1, x plus 1 by x, x cube plus 3x square plus 2. Let me write another algebraic expression for you like x square plus 1 by x square, right? Now these all are algebraic expressions, right? Out of these, only this and this, these two are polynomials. This is not a polynomial, this is not a polynomial. Why? Because the algebraic expressions with non-negative powers, non-negative integral powers. So what did I say? Algebraic expressions with non-negative integral powers. Now we have just finished the number system, so you know what are non-negative integers. Non-negative integers are 0, 1, 2, 3, 4 and so on, which are also known as whole numbers. So the algebraic expressions where the powers, that means this powers of this x in this case, right? So where these powers are whole numbers, okay, only those algebraic expressions are known as polynomials. Okay, so let us talk about x a bit. Now when I write x square plus 3x plus 1, let us say, now these x, when I write x is a variable, right? When I put a value of x, this expression here will give me a certain value. For example, if I put x equal to 1, it will give me 1 plus 3 plus 1, 5, right? So this will be equal to 5 if I put x equal to 1. I can put x equal to 2, it will give me another value, for example 4 plus 6 plus 1, which is 11. So if I put x equal to 1 in this, it will give me 5. If I put x equal to 2 here, it will give me another value which is 11, right? So this value of this expression or polynomial in this case depends on the value of x, right? So x is independent variable, independent variable, okay? And let us say if I equate it with some other variable, then this variable is dependent variable. Right now we are not concerned with y, but I just want to tell you that x is an independent variable. So x will change its values, you can put different values of x and this expression will give you different values. If you consider it to be equal to y for an instance, then y's values will depend on values of x. That is why it is known as dependent variable and x is known as independent variable. Look at another thing, x square plus, let me take this same expression here, okay. Apart from the variables, which terms do you see here? We see that there is this 3, okay. This is known as coefficient. Now coefficient of what? Coefficient of x, okay. Now if I ask you what is the coefficient of x square in this, you can imagine this x square as 1 into x square, right? So coefficient of x square is 1, okay. Now this term doesn't have any variable with it, okay. So this is known as constant, this is constant, okay. Now in this polynomial or in this algebraic expression, we could see that these coefficients are 1, 3, right? But there may be polynomials like this, ax square plus bx plus c. Okay, here the coefficients are a, b and the constant term is c, right? Now a, b, c, these are also real numbers. This sign means belongs to, and this r I have used for real numbers. Okay, these a, b, c are real numbers, that is fine, but these are constants. Okay, they will not change their value. All we can change is x. So we can put x equal to 1, x equal to 2, x equal to 3, and when we put various values of x, this expression will give us various values for itself. Okay, so this is one thing. Now we can categorize these polynomials, that is the algebraic expressions with powers as whole numbers, in some categories. Okay, here first thing that I want to highlight is that we are discussing only polynomials in one variable only, right? That is, for now I am taking the variable as x. You can take x, y, z, any variable or any alphabet out of this. Generally we use x, y, z as the variables and alphabets a, b, c as constants. This is what we do generally, right? It does not mean that a, b, c cannot be used as variables, but it is general convention that we use x, y, z as variables. Okay, in most of the questions when I am talking about only one variable, I will be using x. Okay. Also, if I write, let us say a polynomial x cube plus 3x square plus 5x plus 3. Okay. Now this polynomial is, let us say, p of x. Okay. Now what is this p of x? It means that I am denoting this polynomial by this here, p of x. What it means is, it depends on the values of x. The polynomial p of x will depend, the value of p of x will depend on the values of x. You may see q of x somewhere, r of x. These all are just the ways to denote a polynomial, that there is a polynomial whose value depend on value of x. Okay. Now you may have some other variable. In that case you will see expressions like this, p of y. Now y plus 5, let us say. This is a polynomial in y, right? The variable I used here is y. Okay. Now to categorize these, if I have, let us say, only one term, okay, I may have two terms, I may have three terms, okay, and then four terms. Depending on the terms, depending on number of terms, the categorization or classification or categorization will be as follows. What? If you have got only one term, so one term, for example 3x or let us say 5x square or 7x cube, right? These are only one term, right? So these kind of polynomials are known as monomials, right? Mono means one, so these have only one term. Now if they have got two terms, for example 3x plus 1 or 5x square plus 3x, etc., right? These type of polynomials are known as binomials. Okay, if you have got three terms. Now when I say terms, what do I mean? If I write something like this, 5x square plus 3x minus x square. Okay.
Now, subscribe to Bright Tutee course at ₹1 per day only. Download Bright Tutee app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Tutee courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Tutee follows 3-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tutee and avail your courses at affordable prices.
Are these three terms? No, these are just two terms. I have written 5x square minus x square here. So, I will write 4x square plus 3x. So, this is a polynomial with two terms only. So, this will come in the category of binomials, right. If this was allowed, then I cannot categorize a polynomial in monomial, binomial, etc. because this polynomial here, that is 4x square plus 3x, can be written in infinite number of ways, because I can write it as 6x square minus 2x square plus 3x, or 6x square minus 2x square plus 5x minus 2x. I can keep on increasing the number of terms, but the key is that we are looking for like terms, where the powers of x, let us say powers of, we have got second power of x, that is x square. Okay, so all the terms that have x square in them are clubbed together. So, terms with same powers of variable are to be clubbed together. Only then this categorization will make sense, right. So, these two have to be clubbed together and these two have to be clubbed together. So, this will be the polynomial with two terms, that is binomial. I wanted to give you an example of three terms polynomial. It will be known as trinomial, and example I am writing here, 3x square plus 5x plus 2, let us say. It has got three terms, right, with different powers of x. Okay. So, it has got three terms, so it is trinomial. So, we have categorized it depending on number of terms. One term we call it monomial, two terms binomial, three terms trinomial. Similarly, we can go on like this. More than three terms we will generally call it polynomials. It does not mean that we will not call these as polynomials, these are also polynomials, right. So, this was about categorization depending on number of terms. Now, we will categorize polynomials depending on powers of variable, depending on powers of variable. Now, let us look at the polynomials once again. If I write 3x plus 2, okay, this has got power of x as 1, okay. What is power of x in this? Power, or we can say exponent of variable x is 1, right. 3x plus 2 is just 3x raised to power 1 plus 2, okay. So, when we have got power as 1, I am writing the powers here. If power is 1, we call such polynomials, for example 3x plus 2, linear polynomials, right. When the power of variable is 2, when I say power of variable, I mean the highest power, okay, because if I take an example of second power, that is when the variable is raised to second power, for example 3x square plus 2x plus 3. Now, in this some of the students may argue that x also has power 1 in this case, right. So, this may be linear. No, we are looking for the highest power. Highest power in this expression is 2. Okay. So, when the power of variable, the highest power is 2, we call them quadratic polynomials. This is quadratic polynomial. Okay. When the highest power is 3, for example, let me take 3x cube only. Okay. There may not be other terms. Okay. We call such polynomials as cubic polynomials. If the highest power is 4, for example, 3x raised to power 4 plus 5. Okay. These are known as biquadratic. Polynomials. Okay. So, this is the broad categorization. We can go on with 5th power, 6th power, right. So, this is about categorization of polynomial depending on powers of x. Now, I gave certain emphasis on highest power of x. Okay. Highest power of x, or let us say variable in general, is known as degree of polynomial. Degree of polynomial. Okay. Highest power of variable in a polynomial is also known as degree of polynomial. So, if I ask you what is the degree of this polynomial, linear polynomial, you will say 1. Degree of a quadratic polynomial, you will say 2. Degree of this polynomial is 3, which is cubic, right, and degree of this polynomial is 4. So, these are also degrees here. Now, let me ask you a question. If I write here only 3 without any x, right, this is a constant term, but you can imagine in your mind that 3 can also be written as 3x raised to power 0. So, what is the degree in this case? It is 0. Okay. And these polynomials are known as constant polynomials. Constant polynomials. Okay. Now, if I write only 0, is it a polynomial? Yes, it is a polynomial, because this can also be written as 0 into x raised to power, let us say 1, 0 into x raised to power 2, or 0 into x raised to power 0, right. So, 0 is also a polynomial, yes, and this is known as 0 polynomial. 0 polynomial. Now, if I ask you what is the degree of this polynomial, I can write it in this form, this form, this form, or I can keep on going increasing the powers of x. It will still be 0, right. 0 into something is 0. Okay. So, degree cannot be defined in this case. So, degree of a 0 polynomial is not defined, right. So, what have we learned so far? That we can categorize polynomials on the basis of number of terms, that is monomial, binomial, trinomial and polynomials, etc. We can categorize the polynomials depending on highest power of the variable, which we call degree, right. So, we can categorize the polynomials on the basis of degrees, right. If the degree of a polynomial is 0, it is a constant polynomial, right. If the degree is 1, it is linear polynomial. If the degree is 2, it is quadratic. Degree is 3, it is cubic polynomial. Degree 4, it is biquadratic polynomial. After that, we can keep going on. If we have got a 0 polynomial, and we are asked about the degree of this polynomial, we will say that it is not defined. Okay. If the reason is to be asked, we can say that 0 polynomial can be written in these forms: 0 into x raised to power 5, 0 into x raised to power 225, right. So, there can be infinite degrees, right. It will satisfy at every power of x. You understand that? So, we cannot really define its degree. Which one is its degree? We cannot really comment about it. So, it is not defined, right. So, degree of a 0 polynomial is not defined. Okay. Now, let us look at one more interesting thing here. If let us say we have got a quadratic polynomial. Quadratic polynomial. If I write it as ax square plus bx plus c, how many terms are there? There are 3 terms, right? Can there be 4 terms in a quadratic polynomial? Let me try. Highest power of x has to be 2, okay? So, if I write ax square plus bx plus, let us say, c minus d plus d, okay, if I try to increase its number of terms. Now, what I am doing here is, this is c itself, right? It is the constant term. I am just separating the constant term, right? So, I cannot increase the number of terms. In a quadratic polynomial, you can have at most 3 terms. You can have less than 3 terms because ax square is also a quadratic polynomial. When I say a is not equal to 0, it is a quadratic polynomial. B can be 0, C can be 0, okay. This is still a quadratic polynomial because it has got highest power of x as 2, okay, and a is non-zero. So, it is a quadratic polynomial, but it has got number of terms as 1. What are the maximum number of terms? It can have 3. So, whatever you have as the degree of variable, number of terms will be degree plus 1 at most. This is the maximum number of terms in a polynomial. So, if I write nth degree polynomial like this, a n x raised to power n plus a n minus 1 x raised to power n minus 1 plus n minus 2 x raised to power n minus 2, and keep on going like this. In the end, I will have a naught. Before that, let us say I have a1x, right? If I say that these are an minus 1, an minus 2, a naught, these are constant terms and these are coefficients, right? So, these are coefficients and they are real, okay. So, a naught, a1, a2 up to an, these belong to real numbers, okay. And if this is an nth degree polynomial, then I will have to say the coefficient of x raised to power n is non-zero. In this, I should also say that an is not equal to 0, because if I do not say that, that means an can be 0, right? If an is 0, then this term will vanish, right? And if this term vanishes, what is the highest power of x? N minus 1, then it will not be a nth degree polynomial. This is the logic. So, in this case, when I say that this is a quadratic polynomial, I have to mention that a cannot be 0, okay. Now, rest of the coefficients can be 0. So, a quadratic can have how many terms in at most? 3, right, and minimum number of terms 1, the term with second power. So, in case of nth degree polynomial, if I want to generalize that statement, how many terms can I have at max or at most? I can have n plus 1 terms, right, and minimum only 1 term, that is this one, right. And let me tell you about this coefficient here with the highest power of x. This is also known as leading coefficient. Leading coefficient. So, the leading coefficient cannot be 0, okay, for that polynomial to be of nth degree. Now, what will happen if all the coefficients become 0? A naught, a1, a, all the coefficients become 0, then this polynomial itself will become 0, right? The entire expression will be 0. So, it will become a 0 polynomial. Okay. So, I hope this much is clear to you.
Now, subscribe to Bright Tutee course at ₹1 per day only. Download Bright Tutee app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Tutee courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Tutee follows three-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tutee and avail your courses at affordable prices.